So guys, in this video we will discuss about the Fourier series. So first of all we have to know that what is Fourier series. So here I'm just going to discuss with you that how can you find the Fourier series or what is Fourier series. So here this is the first slide and this is the definition of what is Fourier series. That is, we can say the trigonometric expansion of any function f of x. Most of the cases it is the algebraic function f of x is of the form f of x is equal to a0 by 2 plus summation over n is equal to 1 to infinity an cos nx plus bn sin nx. So now the question is that how can we express a function f of x in this form, or how can we find these undetermined coefficients like a0, an and bn. This is the now most asked questions in your mind, that how can you find this a0, an and bn. So now how can you find the determination of Fourier coefficients? And these are known as the Fourier coefficient. A0, A and Bn. This is known as the Fourier coefficients A0, A and Bn. So here, first of all, we know that of the trigonometric function like cos nx, sin nx, all are defined over the minus pi to pi. So here we consider the function that f of x, if converges uniformly, then we can find the Fourier coefficient a0 and bn by using this formula. That is, a0 is equal to 1 by pi integration over minus pi to pi f of x dx, an is equal to 1 by pi minus pi to pi f of x cos nx dx, and bn as the 1 by pi minus pi to pi f of x sin nx dx. That means here an is the series of cos nx and bn is the series of sin nx. So now there is no question. Now also there is a question that in under which condition we can find the Fourier series. So here now I'm going to discuss with you the new condition that is known as the Dirichlet's condition. So what is the Dirichlet condition? That is, if we consider a function f of x is said to satisfy Dirichlet's condition on an interval minus pi to pi if between these a and b, if any one of the postulates or any one of the condition is hold. So what is the first condition? The function is must be periodic and with period 2 pi and integrable over the interval minus pi to pi and piecewise monotone or minus pi to pi. So now I think there is a question in your mind that what do you mean by piecewise monotone? The piecewise monotone means, actually the monotone means, here we can tell one function that if function is said to be monotone, that means it may be monotone increasing, it may be monotone decreasing. That means monotone increasing, I think you know, then monotone increasing means that m dash x is greater than 0, and monotone decreasing, in short we write md, that is f dash x is less than 0. So now the piecewise monotone means, suppose if we consider here, I just show you by one example, like you just find it the function f of x is equal to x in the interval 0 comma 1. So now you just see here that if you follow, this is 0 line and this is 1. So can you write this is 0 half 1? So now here I am right. Similarly, you can define it also well like this, 0 to half. Union half 3 by 4. Union 3 by 4 1. And now if you find the f dash x, that is 1, and now check that every interval this is greater than 0 or less than 0. That is the concept of piecewise monotone. That means you just piece the given interval into some number of finite intervals or infinite number of sub-intervals. These are the known as the sub-intervals. Sub-intervals. These are known as sub-intervals. And now what is the second? That if f of x is a finite number of point of discontinuity in the interval minus pi to pi, when arbitrary small neighborhoods of these points are excluded and f of x is bounded remainder of the interval, and we can break it into finite number of discontinuities of intervals in which f of x is monotone. I will discuss it in the later. And now here I'm just going to solve the one problem by using this first condition when the given function is satisfy the first condition of the Dirichlet condition. And before solving it, we have to know one thing. This is the points to be remembered. That is, we have to use this formula here. That is, f of x, a function is odd. Then we know that minus a to a f of x dx is equal to 0. And when we can say a function f of x is odd, that is a function that is f of minus x is equal to minus of f of x. And when f of x is even, that holds this relation, that is integration over minus a to a f of x dx is equal to 2 into integration over 0 to a f of x dx. That means, and this is the condition when we can say the function f of x is even, and this is the condition when the function f of x is odd. So now here I'm just going to show you that how can you find the Fourier series. Okay, see here that here we consider this question that find the Fourier series of the function f of x is equal to x in the interval minus pi to pi. So now let us discuss about this problem. So here see that this is the Dirichlet condition. First of all, this is a bounded function. And this is integrable. Integrable means the basic condition of integrability, that is the function is continuous. That means here this is a polynomial of degree 1. And we know that every polynomial function must be continuous. This is a polynomial of degree 1, so we can say this is integrable. And bounded means it has a maximum value, we can find or a minimum value. See here in this interval we can find the minimum and maximum value of this function. So whatever, and it is also, you can break it into the some finite interval, and you can check that if here a plus x is equal to 1, which is always greater than 0. So in every interval you can, every sub interval it is piecewise monotone. So now here we can use this formula to find the Fourier series of the function f of x is equal to x. So now let's see that how can we find it. So see here that here a0 is equal to 1 by pi integration over minus pi to pi f of x dx. So here 1 by pi minus pi to pi x dx. So now just check, this one is a, here f of x is equal to x is an odd function, in the interval minus pi to pi. So here we will get the value is 0. So now in the next, what we have to find, that is an. So how can we find an? That is an is equal to 1 by pi minus pi to pi f of x cos nx dx. So how can we find this one? This is 1 by pi minus pi to pi x cos nx dx. And see here that if you consider that f of x is equal to x cos nx, then f of minus x is equal to minus x cos nx, that is minus f of x. So we can say that this one is a odd function. So here x cos nx is an odd function. So it will be 0. So in the next we have to check where we have to find the bn. So how can we find the bn? Bn is equal to 1 by pi minus pi to pi f of x sin nx dx. So from here what we get, 1 by pi minus pi to pi x sin nx dx. And you can check it here that this function f of x is equal to x sin nx, whereas f of minus x is equal to plus x sine nx, because you know that sine of minus nx is equal to minus sine nx, and f of minus x is equal to minus x. So if you multiply it, so you get f of x is equal to plus x sine x. So this is now a even function. So here we will use the property of even function. So now here I'm just going to the new slide, that bn is equal to, we can write 2 by pi 0 to pi x sine nx dx. So now we have to integrate it by using the integration by parts. So from here we can find it 2 by pi minus x by n cos nx minus integration over ddx of x integration sine nx dx 0 to pi. And so if we put here minus x by n cos nx minus, here we will get 1 by n cos nx dx 0 to pi. So from here what we get? It is minus x by n cos nx plus 1 by n square sin nx. So see here that if we put the upper limit and lower limit in this portion, that is sin n pi is 0 and sin n0 is 0. So this part will be disappeared, only this part will left. 2 by pi minus x by n cos nx, and here if we put the upper limit and lower limit, it will be vanished. And so if we put the lower limit, upper limit, so here we get minus 2 by n cos nx n pi cos n pi, and we know that cos n pi is equal to minus 1 whole to the power n. So from here we can write minus 2 by n or minus 1 whole to the power n. And now see that from here we can easily write that when n is odd, we will get 2 by n, and when n is even, we will get minus 2 by n. So now from here how can we solve it? So from here we can write it, this is 2 by n when n is odd and minus 2 by n when n is even. So now we have to write the Fourier series. So how can we write the Fourier series? So let's see that how can we write the Fourier series. So here what we get from here, that is a0 is 0, an is 0, and bn is equal to, we will get, that is 2 by n when n is odd and minus 2 by n when n is even. Bn 2 by n when n is odd and minus 2 by n when n is even. So here the series will be f of x is equal to a0 by 2 plus summation over n is equal to 1 to infinity cos nx plus bn sin nx. So n0 a0 0, so the series will be is of the form b1 sin nx plus b2 sin 2x plus b3 sin 3x plus b4 sin 4x and so on. So here what will be the value of b1? From here we will get the b1 will be 2 by 1, b2 will be minus 2 by 2, b3 will be 2 by 3, b4 will be 2 by minus 4. So from here if we put the value of b1, b2, b3, b4 and accordingly all, so we will get the series is of the form sin x by 1 minus sin 2x by 2 plus sin 3x by 3 minus sin 4x by 4 and so on. So this is the Fourier series of the function f of x is equal to x. So I have to understand that how can I find it. And now here I am just going to show you the problem where the infinite discontinuities exist. So say in this question that you have to find the Fourier series of the function f of x is equal to. This is defined by minus pi by 4 in the interval minus pi less than x less than 0 and pi by 4 0 less than x less than pi. So here this is defined by like this, minus pi by 4 and pi by 4 0 less than x less than pi by 4. See here there is an x is equal to 0 is a point of discontinuity, and also this function and the except x is equal to 0 you can find a constant function, and you know that the constant function is always continuous. So here we can use the Fourier transform. So how can you find the Fourier coefficients? A0 is equal to 1 2 by pi minus pi to pi f of x dx. So from here we get this is 1 by pi minus pi to 0 minus pi by 4 dx plus 0 to pi. The value of f of x is 0 to is pi by 4 dx. So from here what we get? This is 1 by pi. This is minus pi by 4. So it will be plus pi square by 4 plus pi square by 4. So from here what we get? That is pi 1 by pi, the pi square by 2. So from here we will get pi by 2. So we will get from here pi by 2. Similarly, so now we have to find the an and bn. How can we find the an and bn? We can find the an and bn, that is an is equal to 1 by pi minus pi to pi. So from here we can find it. Minus pi by 4 cos nx dx plus 0 to pi pi by 4 cos nx dx. So from here what we get? 1 by pi minus pi by 4n sin nx in the interval minus pi to 0 plus pi by 4n sin nx 0 to pi. So see that sin n pi is always 0, sin 0, so this will be 0. Now we have to find the value of bn. That is 1 by pi minus pi to pi f of x sin nx dx. So 1 by pi minus pi to 0 minus pi by 4 sin nx dx plus 0 to pi pi by 4 sin nx dx. And if we simplify now it, we will get pi by 4n cos nx minus pi to 0 minus pi by 4n cos nx 0 to pi to 1 by pi. And if we now simplify, what we get? That is, we will get 1 by 4n, 1 by 4n, 1 by 4n, 1 minus cos n pi minus cos n pi minus 1. And if we simplify from here, we will get 1 by 2n, 1 minus cos n pi. So from here we can get it by like this, that from here we get 1 by 2 and 1 minus cos n pi, 1 minus 1 whole to the power n. So that is from here we can get, that is 0 when n is even and 1 by n when n is odd. So now here the Fourier series is of the form f of x, where we get the value of a0, is pi by 2. That is a0 by 2. Here we will get the value is pi by 4, an is 0, and here bn, that is sin x by 1 plus sin 3x by 3 plus sin 5x by 5, and so on. So this is the Fourier series of the function f of x is equal to minus pi by 4 and pi by 4. So thank you for watching the video.